Hello, physics. Today I want to go through some of the 1D motion problems that we've been working on. So this problem should look familiar. A driver is traveling at 28 meters per second, suddenly notices a penguin on the road. Don't want to stop and hit the penguin. Don't want to hit the penguin. The driver only has 18 meters in which to stop. Stop. 3, 2, 1, go. Hello, physics. So today I want to take a look at some of the 1D motion problems that we've been looking at. So this problem should look familiar. A driver traveling at 28 meters per second suddenly notices a penguin in the road. The driver only has 18 meters in which to stop the car. What acceleration is needed to stop the car, and also how much time is needed to stop the car. And over here to the right, I have the AP motion equations written down for reference. So let's apply the 8-step plan and solve this problem. So for the 8-step plan, the first thing I want to do is use some active reading, and I just want to circle and underline the important information of the problem. So 28 meters per second looks pretty important. The driver suddenly notices the penguin. The driver only has 18 meters in which to stop the car. Now, we are stopping the car. So that's important because if I'm stopping the car, that's telling me a piece of hidden information. All right, so I'm going to put my origin at where the driver applies the brakes. So I'm putting my origin right there. That's important to know. So a driver traveling at 28 meters per second, the second step of the 8-step plan is assigning variables. So this should be V naught. 18 meters should be my variable X. And the fact that I'm stopping should tell me that the final velocity is equal to 0 meters per second. So I always said to make a sketch. We have a picture here to work with, so this is pretty good. So I know here in this picture, if that's the origin, then I am starting with my initial position of 0. This distance here is 18 meters. That then should be, I'll end at X away from the origin. And I know that this car has an initial velocity of 28 meters per second. So I have a good understanding of what's going on in this problem. Now, if I didn't have a picture, making a sketch would have been that much more important. Remember, if you cannot sketch the physics problem, you don't understand the physics problem. Once I have everything labeled and I have convinced myself that I know what's going on, then the next thing I'm going to do is just make a list of all the possible motion variables. And so I can take an inventory of what I know and what I do not know. So position, initial velocity, final velocity, acceleration, and time is what I have to work with. So my initial position is 0 meters, so that's fine. My final position should be this 18 meters. My initial velocity is 28 meters per second. My final velocity, because I'm stopping, should be 0 meters per second. And I do not know the acceleration, and I do not know the time. Now, since this problem is asking me to find both the acceleration and the time, I could do either one of these variables first. I am going to solve for the acceleration first because I can do that, but it is perfectly okay if you opted to find the time first. The time first would involve a little bit of extra work. Scratch. 3, 2, 1. So the problem is asking me to find both the acceleration and the time. It's asking for the acceleration first, so that's where my attention is going to gravitate to. You might try to find the time first, but you'll discover that in this problem, you'd have to solve for the acceleration regardless, unless you use the version of the problem that's not, of the motion equation that's not on the AP equation sheet. And let's just write that one down again. So a very useful motion equation that's not on the equation sheet is that x minus x naught equals 1/2 v naught plus v times t. Now, this version of this motion equation would allow me to find time first, but since it's not on the AP equation sheet, I'm going to pretend that I do not know this equation. So let's find the acceleration first. So I do not have the time. There is only one equation up here that does not use time, so let's start with that. I'm going to drop the x subscripts because we're only working in one dimension. So it is assumed that all these variables are for x. So I have v squared equals v naught squared plus 2a x minus x naught. Now, the next thing I like to do is simplify things by eliminating zeros in the problem. I know that v squared is 0 and that x naught is 0. So this equation simplifies to 0 equals v naught squared plus 2a times x. Now, another good step to do is to take an inventory to make sure that we only have one unknown in this equation. If there was more than one unknown, then we would need a system of equations. But I do know what the initial velocity is, so that's good. And I do know what x is, so the only unknown in this equation is a. So I'm ready to proceed. So the first thing I'm going to do is move the v naught squared over to the other side. I get minus v naught squared equals 2 times the acceleration times x. Don't do the algebra in your head. Work the algebra out step by step. I am looking for the a, which means I need to divide by the 2 and the x. And so I will get that a equals minus v naught squared divided by 2 times x. And then I can put in my numbers. So this will be minus 28 meters per second squared divided by 2 times 18 meters. I'll let the viewer put the numbers into the calculator to find the final answer. But I note that this is a negative acceleration. And that actually makes sense. My acceleration here, my velocity here is to the right, which means if I want to stop this penguin, take away this velocity rather, then my acceleration, which needs to be equal to pointing to the left, so it needs to be negative, because I point out that acceleration is a change in velocity over a change in time. So we can think of acceleration as how much velocity we take away or add every second. So if my velocity points to the right to stop, I need to take away velocity by adding negative velocity to it, and so the acceleration will point in the opposite direction. All right, let's solve the second part of this problem. The second part of this problem, define the time. That's relatively easy. Let me keep it blue. Define the time. I note that the velocity equals the initial velocity plus acceleration times time. I know the initial and the final velocity. I now know the acceleration, so solving for time is easy. So I know that v minus v naught will be equal to acceleration times time, or that time will equal to v minus the v initial divided by the acceleration, or that time would be equal to, that's going to be 0 minus 28 divided by a, whatever value you got for the acceleration up there. That will give you the time. I hope this made the method clear, and there'll be another video discussing the police and speeder. Good night.